So the lower end is still the sensitivity only, but upper end, you see, I am going to measure the intermodulation product. So we have seen harmonic distortion, right? So like that, we have what is called as intermodulation products. So those products, what is the maximum power? If I'm going to measure that, that is going to be the SFTR. Maybe regarding intermodulation product, I will we'll derive the expression for SFDR shortly, so that time you'll understand what is third order IM. See, when you have same frequency integer multiple is called as harmonic. When you have like this m f1 plus or minus n f2, when you have multiple frequencies being added, it is called as intermodulation products. The same frequency integer multiple, it is called as harmonic distortion. If you have combination of two frequencies or three frequencies, it is called as third order or higher order intermodulation products. That is the case we are going to measure for SFDR. So the ratio, if you take, again, you will get SFDR. So power of each tone to sensitivity is going to give you SFDR. So when you derive the expression for SFDR, you understand what is meant by IM product. For now, understand IM means a linear combination of two frequencies which are mixing to produce an interfering frequency. That level of understanding is enough as of now. So SFDR will represent the maximum level of interference a receiver can tolerate. So if there are 100 interferers, how much your receiver can tolerate, that is going to be the measure of SFDR, whereas dynamic range will say what is the maximum power level your device can handle. So both are giving two complete dimensions of noise. For both of them, the lower bound is going to be the sensitivity, and for dynamic range, the upper bound is going to be the maximum power your device can tolerate, and for SFDR, the upper bound is going to be the power of the third order IM product. Okay, that is going to be the maximum upper bound for your SFDR.